George Boole had laid down the logic for binary arithmetic called Boolean algebra in the 1800s. Wow, that dude was insane. This means that we had a solid foundation to work with for binary logic and did not have to conceptualize many new ideas to keep our binary system active. He used this primarily for dealing with logical statements where things can be either true or false, but it fits very nicely for our binary manipulations.
Logic deals with true and false, where it is synonymous with the earlier mentioned on means electricity is flowing and off means electricity is not flowing.
The main operators are AND, OR, NOT, and XOR. These operations work on 2 bits at a time, and as such are called bitwise operators. Like how we have multiplication tables, we have something known as truth tables, which say if the output is going to be either a true or a false, given the true or a false of 2 other bits. If you look at the case of an AND, bit 1 and bit 2 must be true and must equal 1. Otherwise, it's going to give a 0 as an output. In the case of an OR gate, either bit 1 or bit 2 must be true. So you should have 1, 1. Otherwise, everything is a 0. In the case of a NOT, it just flips your bit. So if you're a 0, it makes it a 1. If you're a 1, it makes it a 0. In the case of an XOR, if bit 1 is 1 and bit 2 is 0, or bit 1 is 0 and bit 2 is 1, it's going to show you an output of 1. It only turns on if there is an odd number of ones, which denotes a difference in levels. So if 2 bits are different, then that's when an XOR fires.
It's time for a quiz now. Go to the link mentioned in the video and start.